Hello, I'm Brielle Merkley, and today we are going to break down what gravitational waves are, how they form, and how scientists can detect them here on Earth. According to the theory of relativity, massive objects like black holes or neutron stars warp spacetime, which is the four-dimensional fabric of the universe. When two such heavy objects orbit each other or collide, they disturb spacetime in a way that sends out waves, distortions propagating through the fabric itself. These are called gravitational waves. The waves move outward at the speed of light, carrying information about the massive event that caused them. Even though these waves are incredibly tiny by the time they reach Earth, scientists built special observatories to detect them. Don't worry, I'll get into that in a minute. To illustrate what gravitational waves do, I'm going to use water in a baking dish. When I drop this marble, you see circular ripples spreading outward. In our analogy, the water surface is like spacetime, and the marble splash is like a massive event, a black hole collision, for instance, sending out waves through spacetime. If there are two objects or a merging pair, their disturbance can create overlapping waves. Similarly, gravitational waves form complex cosmic events that combine and shape the patterns of spacetime ripples. Notice how the ripples fade as they move outward, just like real gravitational waves fade the farther they travel, which is why by the time they reach Earth, they're incredibly subtle. However, this is just an analogy. These waves travel through a medium, water, but gravitational waves travel through spacetime, so there isn't a medium in the usual sense. Still, this helps us picture what's happening. To detect these faint spacetime ripples, scientists use LIGO, the Laser Interferometer Gravitational Wave Observatory. It has two long arms arranged in an L shape that are both 4 kilometers long. A laser is split into two beams that travel down each arm, bounce off mirrors, and return to the detector. Gravitational waves stretch one arm and squeeze the other by an amount smaller than a proton. That tiny difference changes how the beams line up when they return to Earth. That mismatch is how LIGO hears a gravitational wave passing through Earth. Detecting gravitational waves lets us study parts of the universe we can't see with the normal telescopes, like black hole collisions, neutron star mergers, and other extreme cosmic events. They give us a whole new way to observe the universe by listening to spacetime itself. Gravitational waves help us understand the universe in a totally new way, beyond what telescopes can even show us. I'm Brielle Merkley, and thank you for exploring gravitational waves with me.